All right, welcome back. Let's do this. 5.3 day 3 start. So, 5.3 day 3 is mostly a review, and I'm gonna breeze over the review like I did last time because if you want an actual review, you don't need a review. You just go back and look at the videos that I recorded over the last ones. Really, we're just gonna be looking at solving quadratics that give you complex solutions. All right, so let's get started. So don't write this down. This is just me going over this refresher. So the idea here is, right, that you can use square rooting to get rid of a square. So you got a square here and it's bundled up with this x. And instead of like foiling and doing all this gross stuff, just get this piece by itself and then square root both sides, right? That's the idea. So just follow along visually, right? So I would, looking at this equation, you try to isolate the base, and so this is the base, and you'd want to isolate that by adding 6 to both sides, and then you would get 2x plus 1 quantity squared equals 25, and then you would square root both sides, and when you square root, you have to remember the plus or minus. That would give you 2x plus 1 equaling plus or minus the square root of 25, which is 5. And then you would, ignore this part over here. Don't let that confuse you. Just do the 2 steps necessary to solve for x here. And that would be to subtract 1. So you subtract 1, and then you'll be dividing by 2. And so you'd get 2x equals, and then this is like negative 1 plus or minus 5, or plus or minus 5 minus 1, right? Whichever one you want to think about. It's just semantics to argue about which one you should do it as. They are both exactly the same. So you divide by 2 to get rid of the 2 here. And then you have x equaling negative 1 plus or minus 5 over 2. And that gives you 2 solutions. One where you use the plus and simplify, one where you use the minus and simplify. So you'd get negative 1 plus 5 over 2 and negative 1 minus 5 over 2. And so this is 4 over 2, which is 2, and this is negative 6 over 2, which is negative 3. And so those are your solutions, right? Hopefully you followed along there. It's just a bunch of grunt work after you understand what it is you're doing, right? It's a lot of familiar steps with just a couple of new things. So now we're going to get into what's going on in this lesson. So solving quadratics with complex solutions. So take the normal steps you would to solve using square roots like on slide 2. So you don't have slides, but like above, right? So if/when you square root a negative, simplify using I, right? So the idea here is you want to do exactly the same thing we've been doing, except sometimes you might run into square rooting a negative, and then you just use I. So let's look at this and try to solve it. So the idea here is you want to get that x by itself. So you got to subtract 27 from both sides. And then you get 3x squared equals negative 27. And then you divide by 3. And then you get x squared equals negative 9. And then you square root both sides, remembering the plus or minus. And you get x is equal to, because the squared and the square root cancel, so you don't have a squared anymore, and it equals plus or minus the square root of negative 9. And if you remember from what is it, day 1 of 5.3, this simplifies by looking at either a shortcut method where you can consider the negative to be an I at the end, and then that's the square root of 9, which is 3. So that's what the solution is. But if you've forgotten about that, remember that you can break negative 9 under the radical into this, the square root of 9 times the square root of negative 1, because negative 1 times 9 is negative 9. And so the square root of negative 1 is defined to be I, and the square root of 9 is 3. So that is 3I, and you have a plus or minus. So your 2 solutions are 3I and negative 3I. Those are your solutions. Okay, fair enough. So, something that a lot of my students might be asking or thinking is, how do I know? Like Mr. Dybel, you were just telling us that we had to like get it equal to 0 and then factor and then set each factor equal to 0, and now we just have to square root. What's the deal? How do I know what to do and when? Well, that's all contextual. It's all based on the problem you've got. You take the information you're given, the problem you're given, and you solve it in the most convenient way. So when you have a single x being squared, or after simplifying, you just have x squared and you don't have any x's to the first power, that is when you'll be using square roots. The problem is if, all right, this is like a hypothetical situation, so just try to follow along and don't write this down. If you had a situation that was like this, instead of 3x squared plus 27 equals 0, if it was like 3x squared plus 2x plus 27 equals 0, you can't just square root the square away. Because when you square root, you have to square root everything, right? So you'd have to square root, first off, this is not even doable. You would have to move this over and then square root one side and square root the other side. But the problem is you'd have the square root of x, and that's not going to cancel with anything. There's not like an x squared here to cancel. So the idea is that you don't want to use square roots to get rid of squares if there's still some x here by itself. So you only want to use square roots in situations where you have a single x being squared after simplifying, okay? So in situations where you've got an x squared term and an x term and a number, that's the situation in which you want to factor. But if you just have the x squared and the number, then you can get rid of the square root by, or get rid of the square by square rooting, excuse me. All right, so anyway, let's move on. Let's try this example out. All right, so on this one, we've got the quantity x minus 8 being squared equals negative 25. All right, so here, the main idea is to get the base by itself. And your x minus 8 is the base of this exponent. Every exponent has a base, and the base is what is being raised to the exponent. So the x minus 8 is the base. And if there's anything else here, you have to get rid of it. But there's not. And so now you just immediately go into square rooting. And you plus or minus the square root over here. And you get x minus 8, because the squared went away, equals plus or minus the square root of negative 25. And we actually worked out the square root of negative 25 on the last lesson. So, or maybe day one. So, as just a refresher here, the square root of negative 25 breaks down into the square root of 25 and the square root of negative 1, and that is 5i. So that's the idea here. So you've got x minus 8 is equal to plus or minus 5i. So yes, now we have I in our solution, just like we did here. And what you want to do at this point is solve this for x over here. And so you would add 8 to both sides. And you end up with a big mistake students make is that they try to say that this is like 13i when it is not. Remember that I is treated just like x. So if you're saying that this is like 13i, then you must also be saying that like 5x plus 8 is 13x, and it is not. Remember, you can only combine like terms together. And so i's and real numbers cannot be combined together through addition or subtraction. So you're going to get x equals 8, so I'm putting the plus 8 at the beginning here, plus or minus 5i. And there's a reason I put the 8 at the beginning this time. It's because when I write my two solutions out, 8 plus 5i and 8 minus 5i, this is in like the regular way to see complex numbers, where you've got a real part and then your complex part. So you got your real part first and your complex part next. So you got your real part and complex part, real part and complex part, right? So that's why I've written it out this way. Okay, so hopefully that made sense. What we wanted to do was get the base by itself and then square root both sides, remembering the plus or minus. Then we simplified the square root over here. That got us to be 5i. So we just replaced it with 5i. And then we did what was necessary to solve for x here. Last problem and then your homework. This is a really quick lesson. So again, try to solve this by yourself if you know how. And if not, then keep following along and you'll get it, I'm sure, if you have a positive mindset. Right? So anyone can do algebra 2 with enough practice. So here, to get this base by itself, remember, when you're solving, this goes all the way back to chapter 1, when you're solving and you're trying to think of what steps you would like to do things to get rid of certain pieces, try to go backwards from the order of operations. So if you look at the problem, you're like, I don't know if I should divide by 2, and maybe this is like an incomplete version of what you should be doing, but you don't know, hey, should I divide both sides by 2? Which would be wrong, because we talked about this also earlier. You'd have to divide everything by 2, which you could do. But so say that's your decision. Or that's one of your choices. You could divide by 2, or you could subtract 10, or you could square root. And you don't know which one to do first. Well, work backwards from the order of operations. If your choices are subtract 10, divide by 2, or square root, then if you work backwards from the order of operations, it'll tell you which to do first. Add and subtract. That's what you want to do first. So you'd subtract 10, and then you would get 2 times the quantity 3x minus 5 squared equals negative 40. Then you would say, okay, do I square root or do I divide? And square rooting is like dealing with the exponent, so you put that there. So you would multiply and divide next. And so you divide by 2, and you would get 3x minus 5 quantity squared equals negative 20. And now you square root, finally. So when your base is by itself, that was always the first step, isolate that base. So now you square root, and you get, I'll put that over here, 3x minus 5, because the square and the square root cancel, equals plus or minus the square root of negative 20. And so now let's simplify the square root of negative 20. We'll do that right here. The square root of negative 20 can be broken down into positive 20, like the square root of positive 20, and the square root of negative 1. And so this is the square root of 20i. But 20 can be broken down further. You could choose to break the square root of 20 down into the square root of 4 times the square root of 5. And you choose 4 and 5 because you know the square root of 4. Right? There's other factors of 20. There's 1 and 20, there's 2 and 10, and then there's 4 and 5. But you don't know the square root of 2, you don't know the square root of 10, you don't know the square root of 20, so you don't want to choose these factor pairs. You choose this one because you know the square root of 4. So this is 2 times the square root of 5. Right? So you still have the I with it, so it's 2i times the square root of 5. So the 2 comes in, the I comes in, and the square root of 5 comes in still. Right? So you've got 3x minus 5 is equal to plus or minus 2i times the square root of 5. Or 2 square root of 5i, it doesn't matter, whichever one you'd like to do. All right. Now you're just going to solve this out for x. So you'd add 5 and then divide everything by 3. So I'm running out of space here. You would get 3x equals 5 plus or minus. Actually, I apologize. The best way to write this right here would be to put the real parts first and then the complex parts last. So I'm just going to go ahead and move that I to the end again. It doesn't change anything, and I do apologize, but I'm going to put the real parts, the 2 and the square root of 5, first, and then I'll put I next, and you'll see why I do that here in a second. So you got 2 square root of 5 and then I. And this is why I do that. Because when you divide by 3, you can divide this by 3 and this by 3. And you end up with the answer of, man, I'm really running out of space. You would have, I'll just try to fit it in over here, I guess. All right, so you would have x equals 5 over 3 plus or minus 2 times the square root of 5 over 3i. And that is your solution. And that's why you want to write the 2 and the square root of 5 together. That way you can pull the I out sideways like this on the side. So it looks like a typical it looks like a typical complex number. Anyway, sorry if that was a bit of a mess. This is my first recording today, but hopefully everything went okay or well enough that you guys can get started on your homework. There's your homework, page 331, 1 through 7. If you have any questions, let me know, and get to work.